Last time on Mastering AMC 1012, we explored algebraic manipulations and how to solve complex-looking equations using our techniques. Today, we're taking a look at Vietas. Make sure to stay till the end of the video, where we'll explore how Vietas can make complex-seeming problems look like a piece of cake. Let's get started. So I'm sure you're familiar with the quadratic formula and how the discriminant determines how many real roots it has. So if it's 0, it has a double root. If it's positive, 2 real roots. Negative, there's no real roots. But what we're really here today is to discuss Vieta's formulas. Starting off with Vieta's formulas for quadratics. In a quadratic, the sum of roots is negative b over a, the product is c over a. So if we have a quadratic like 2x squared plus 7x plus 3 equals 0, the sum of roots is negative of b over a. The product is just c over a, so 3 over 2. Let's take a look at an example, but it's not just going to be a straightforward application. We're going to have to do a little bit of algebraic manipulation. If the roots of the quadratic 3x squared plus 6x minus 5 are r and s, find r cubed plus s cubed. How can we do this? We don't know r cubed plus s cubed with Vietas. Let's figure out what we do know with Vietas. We know r plus s. We know that r plus s equals negative of b over a, negative 6 over 3 is negative 2, and rs is just c over a, so negative 5 over 3. But we're asked to find r cubed plus s cubed. If you watch the factorizations video, you'll know exactly how to solve this. What we do is we cubed r plus s, and this gives us r cubed plus 3rs times r plus s cubed. This was one of the identities in the first video of algebra. So we're asked to find r cubed plus s cubed. So let's plug in negative 2 here. We have negative 2 cubed equals r cubed plus s cubed plus 3 times rs is negative 5/3, so negative 5/3. And then this is also times r plus s, which is negative 2. 3's cancel, and this is just r cubed plus s cubed plus 10. But we're asked to find, we need to find r cubed plus s cubed, so we just subtract 10 from both sides to get negative 8 minus 10 equals negative 18, as equals r cubed plus x cubed. And negative 18 is our answer. So this problem kind of shows a standard Vietas trick, which is cubing using algebraic manipulations sometimes. But in general, it will all come down to these core values, r plus s and rs. Another thing you might see is to find 1 over r plus 1 over s. And notice that this is just r over rs plus s over rs, because these terms will cancel to make 1 over r, and these terms will cancel to make 1 over s. So this is just r over s, r plus s over rs. So you'll often have to do many manipulations to get what you're truly asked to find. The Vieta's formulas isn't limited to quadratics, and no, it gets much more complex when we're dealing with higher degree polynomials. So in a polynomial of the form like this, we're asked to find what does Vietas tell us? It tells us that the sum of the terms, r1 through rn, is negative of this term over this term. The sum of the products of two terms is the positive of an minus 2 times x to the n minus 2. Now I know this seems scary, but let's see how this is used in an actual polynomial. Let's say we have a polynomial, x cubed minus 7x squared plus 36x minus 13 equals 0. The sum of the roots equals negative of negative 7 over the coefficient, which is just 1 in this case. And the reason we have a negative here. Now what we do is to get the sum of, if the roots of this polynomial are r, s, and t, then rs plus st plus rt, that would be equal to positive 36 over the coefficient, which is just 1 in this case. It's not always 1 just in this case, because it's a monic polynomial, coefficient of 1 for x cubed. And then we go back to negative. So r times s times t is just negative of negative 13 over 1, which is 13. So the key here is that we always alternate, starting at negative, then positive, then negative, then positive, and so on. And if it's helpful, you can write them out like this, like I just showed. You can write out negative, positive on top of the coefficients. So then the sum of all the terms multiplied once, r plus s plus t, is just the first term divided by the coefficient of the first term here the second term I should say, divided by the coefficient of the first term times whatever sign that's here, negative or positive or whatever. And next we have the sum of all the pairwise products, so the sum of all possible values of the product of two roots, so rs, st, rt. That's going to be the second term divided by 1 over here. And finally, the sum of all products of 3 terms, so rst, that will just be the fourth term, the term here, divided by this term here with whatever sign multiplied to by. Let me take another example just so you understand. This time we have x to the fourth minus 7x cubed plus 6x squared minus 35x plus 2. Let's find the sum of the roots. What we do is we label negative, positive, negative, positive. Negative of negative 7 divided by the coefficient of 1 here, which is 7. So the sum of all 4 roots, let's say r plus s plus t plus u this time, is 7. And then this time, the sum of all the pairwise products. Now there's not just 3 sums, there's rs plus rt plus ru plus st plus su plus tu. The sum of all of those products of all pairwise terms, that's just positive of 6 divided by 1, the coefficient of x to the fourth. And then the sum of all 3 sums, so rst plus rsu plus rtu plus stu, is just negative of negative 35, because that's the coefficient on this term, divided by the coefficient on this term, which is 1. 35. And then the product, or the sum of all products of 4 terms, but in this case there's only one product for 4 terms when we have 4 terms, is positive 2 over 1 equals 2. And this first term does not always have to be 1. It can be 2 or 3, and we would divide by 2 if that was a 2 instead. Now let's see how we can use this for an actual problem. If r, s, and t are roots of the cubic, x cubed minus 6x minus 5, find r cubed plus s cubed plus t cubed. What should we do here? Well, first let's just write 0x squared, because the common mistake is to see that, just read this as x squared minus 6x minus 5, because there's no x squared term. Be careful here, we have a 0x squared. Always helpful to write that out. You never know. Okay, so what does Vietas tell us? Let's write our standard negative, positive, negative. So the sum of the roots r plus s plus t is negative of 0 over 1, which is just 0. Now the sum of all the products of 2 roots, rs plus rt plus st, equals positive of negative 6 over 1, the coefficient here, equals negative 6. And then the product of the root rst is negative of negative 5, right? Negative sign of negative 5 over 1, which is just 5. But we're asked to find r cubed plus s cubed plus t cubed. What should we do? Do we know any identities, maybe? Again, if you watched class 1, you should definitely watch part 1 of the algebra series, where you remember this identity, r cubed plus s cubed plus t cubed minus 3rst equals r plus s plus t times r squared plus s squared plus t squared minus rs minus rt minus st. I know this looks scary, but we don't even care about the second term. Notice here, r plus s plus t equals 0. So if r plus s plus t equals 0, then this whole term is 0. We don't even care about what that is. We already know r plus s plus t is 0. So this is just 0. And that means r cubed plus s cubed plus t cubed is nothing but 3rst, which is 15. Isn't that cool? So the logic here was to see what does Vietas give us, and then always, not always, but often, you'll want to see what identities you can use. In this case, this identity saved us a lot of computation here. Okay, now we're going to move on to a problem from the AMC 12. The polynomial a cubed plus ax squared plus bx plus c has the property that the average of its zeros, product of its zeros, and sum of coefficients are all equal. The y-intercept of the graph is 2. What is b? First, what does this last condition tell us? This last condition tells us that at x equals 0, p of x equals 2, because the y-intercept is when x is 0, right in the center. What does this mean? What is p of x when x is 0? P of 0 is just 0 cubed plus a times 0 squared plus 0b plus c. This is all 0. So if this is equal to 2, c is 2. Okay, now we're on to our Vietas. What does Vietas tell us, first of all? We know that the average of the zeros, product, and sum of coefficients are all equal. What is the average of the zeros? There's 3 zeros, or roots. We know that r plus s plus t, let's write negative, positive, negative, equals negative a over 1, the coefficient here. Okay, what about the product? But remember, we're asking for the average. So it would be negative a by 3. What about the product? The product is negative c by the coefficient here, 1. Don't forget this coefficient, 1 here. I know it's 1 here and it doesn't really matter, but when the problem says 2, then you'll be tricked, because then it's not just negative c. So always be careful about that 1 term there. So negative c over 1, which is negative c. Ah, we know the value of c. So this is just negative 2. Now sum of coefficients. The sum of coefficients is just 1 plus a plus b plus c. And we're given that this is also equal to both of these terms. First of all, we know negative a over 3 equals negative 2. So that means a over 3 is 2, a equals 6. Right? So this term, the sum of coefficients, is nothing but 1 plus 6 plus b plus 2. But then we see that this sum has to be equal to negative 2, c, or negative of c, which is negative 2, right? Because all 3 of these terms, negative a over 3, negative 2, or negative c equals negative 2, and this over here, they all have to be equal, given by our problem statement. So we know that negative 2 is equal to 1 plus a plus b plus c, or we know b is 6, so we have this equation over here. Let's solve. We have 9 plus b equals negative 2, so b is negative 11. And that's our answer, negative 11. So to summarize, first we plug the condition in, the last one, to get c equals 2. Then we found A based on our condition with Vietas, and then we used that to find B. Okay, now we can move on. By the way, if you look at all these practice problems, you can find them in the book, link in the description. Now we're going to move on to polynomial roots. Vietas is useful, but sometimes it's not the best approach with polynomials. Sometimes we'll have to use these representations, and it's very useful for simplifying problems like this one over here. We'll explore that in the next video. You can find that over here. Thanks for watching, and make sure to like and subscribe if you enjoyed this video.